Hi everyone who's watching this video right now. My name is Qin Qiao. I'm first year international student from China and I'm doing pure physics right now. Of course, I'm from School of Physics and I'm taking the charge of scriptwriter in this group and hope you enjoy this video.
Hi, hello everyone. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Khadega Abdulrahman, Salem, Omar, Albaker. I'm a medical physics student from School of Physics and a first year student. In this video, I would be the editor.
Hi there, my name is Logesh Kumar Analilaki Selvakumar. My matrix number is 158229. I'm a first year pure physics student from School of Physics of University Science of Malaysia. My role in this assignment is presenter. So I hope you enjoyed this video on Northern Lights of Jupiter. Thank you. Aurora. When I say aurora, what crosses your mind?
Take me home where I belong.
Not that singer. We are talking about the beautiful colors appearing on the sky of northern and southern pole of our Earth. Have you seen that? So I'm pretty sure you have seen beautiful pictures of auroras in Google, social medias. But here we are not going to talk about aurora formation on Earth. We are going to talk about the brightest formation of aurora in our solar system. And surprisingly, the northern light of Jupiter is the most brightest aurora in our solar system. So now, before we take a deep dive into the mechanisms of X-ray aurora on Jupiter, let me see what are the observatories used in order to study the northern light of Jupiter. There are basically two observatories used. One of the observatory used is European Space Agency XMM Newton telescope. This telescope orbiting Earth and studying the northern light of Jupiter in X-ray wavelength from the orbit of Earth. And another observatory used is NASA's Juno probe. NASA's Juno probe operates in the magnetic field of Jupiter. So these are the two observatories where the scientists get data from, and they study these data collectively to create images and various kinds of data. Since we have an overview of the observatories where we get data from, let me take a deep dive in the mechanisms of Jupiter's aurora. Let's start with the magnetosphere of Jupiter. The size of magnetosphere of Jupiter is so big, its size reached the Saturn's orbit. Due to this huge magnetic field, the aurora created on Jupiter have tremendous amount of power, gigawatts of power. So scientists try to figure out how this X-ray aurora create using the data from these two observatories. In order to study the northern light of Jupiter, first what they did is they create a model which focuses on magnetic lines going millions of kilometers joining the south and northern part of Jupiter. And scientists able to use 26 hours of data from the XMM Newton telescopes combined with the data from the Juno mission as well. What they observed is there's unusual periodic pulsation every 27 minutes detected by Juno probe. This pulsation indicated that aurora was produced by the changes of Jupiter's magnetic field. With every single pulsation and change of Jupiter's magnetic field, the X-ray aurora produced. This makes us to understand that magnetosphere fluctuations cause X-ray aurora. But the thing is, it doesn't end there. There are 40 years old mystery that can't be solved, but we solved with the recent data. So what are the 40 years old mystery? All about two things. One is how this magnetosphere fluctuations happens, and second, where does this ions that colliding with the atmosphere of Jupiter comes from? With the further analysis of recent data, we get to know that how the ions getting to the northern and southern pole of Jupiter. So, as you know, with the further analysis of recent data we get from the two observatories, we get to know that the sulfur and oxygen ions coming from eruptions on Io. Io is the moon of Jupiter. This moon is particularly active in terms of volcanic activities. There are many volcanic eruptions happens, and when this eruption happens, there are tremendous amount of oxygen and sulfur ion released towards Jupiter's atmosphere. This makes oxygen and sulfur ion deposit in Jupiter's atmosphere and trapped in Jupiter's magnetic field lines. These ions travel to northern and southern part of the Jupiter by a process known as modulated electromagnetic ion cyclotron waves. Modulated electromagnetic ion cyclotron waves are created by compressed magnetic field due to solar winds. When the ions once reach the atmosphere of the part of the northern and southern pole of Jupiter, it creates X-ray aurora. This aurora happens at different time and different region. This is because the huge distance of Jupiter's magnetic field journey by ions. As I said earlier, the size of the magnetic field of Jupiter is so big that it can reach the orbit of Saturn. So the ions literally have to travel millions of kilometers just to get northern and southern pole. So we get aurora at different times and different regions. Now let me see the advantage and disadvantage of the Jupiter's northern light. The advantage is it can help us to theorize how auroral emission on different planets happens. For example, we get to know UV aurora on Saturn. And second is, the X-ray aurora do not poses any harm to human as the Jupiter is quite far away from planet Earth. Third, it helps physicists to understand more about Jupiter's X-ray aurora emission mechanism, characteristics of Jupiter's magnetosphere, and electromagnetic ion cyclotron wave that happens naturally in different planets. The disadvantage is high energetic auroral emission might disturb the Juno probe electrical circuits. Second, violent volcanic eruption from Io moon can cause possible damage to Juno probe. Third, high energetic aurora and Io moon's volcanic eruption is hostile to biological life. So in conclusion, we now not only witness Jupiter's aurora, but also understand how it works. This whole research can be a good reference to study aurora on other planets in the future. That's all from us. Thank you.